Hi, welcome to my Psych Project. I am going to be talking about the brain and be making comparisons and just detailing how it works. Alright, so first up, we're going to be talking about the cerebrum and lobes. Alright, so the cerebrum is the largest part of the brain and is responsible for all your big boy brain functions like thinking, memory, emotion, decision making, and voluntary movement. It's got two halves, two hemispheres, left and right, and there's four lobes, each with different special functions. Alright, so first up, the frontal lobe, front of the brain, and it's kind of like a CEO. Why? Well, it's involved in a lot of your brain functions, like planning, reasoning, problem solving, personality, and movement. It's also used for controlling emotions and behavior, so it's a pretty important part of the brain. Alright, so next, the parietal lobe. It's found near the top and the back of the brain, right here. It processes sensory information like touch, temperature, and pain, along with spatial awareness and understanding where your body is. So, if you think about it, kind of like a map. Shows you where you are on that map, shows you where things are. I mean, sometimes you get elevations on it. But yeah, parietal lobe, kinda important too. And now, the temporal lobe, located on the sides of the brain near the ears, right here. Um, kind of like a mic and speaker, if you think about it. Um, it's responsible for processing sound, language, and memory. Plays a like key role in understanding speech and forming long-term memories. It's quite important if you want, memory. But yeah, if something gets spoke through a mic, you can kind of hear it coming out the speaker. So, yeah, pretty important. And for the last lobe, is at the back of the brain, the occipital lobe. Um, this lobe is like mainly responsible for vision. Um, it interprets your visual information like color, shape, and motion. So it's kind of like a camera screen because I mean, take a picture or a video, and after it takes whatever it was recording or taking a picture of, you can see it on that camera screen. So it's interpreting what it saw. So and you know, as with all the other lobes, pretty important. And next up on our list, right after our cerebrum and four lobes, we're going into the basic functions of the brain. First up, sensory information. And yeah, we're going back to a camera. It's like a camera sensor. It's detecting the input from the environment. So it's the, stuff you see before it gets actually processed. Alright, so motor information. Basically, it is information sent from the brain that tells the muscles to move. This is kind of like a game controller if you think about it. You move the joystick on a game controller, and your character moves in game. That's basically how it's happening, but your brain is sending the instructions to your muscles to move. Alright, and our last for our basic functions is integration, perception, and cognition. It is kind of like a computer processor, a CPU, on how it analyzes, information and makes sense of it. So just like how a CPU takes ones and zeros and turns it into like text you can read, that's what your brain is doing. It takes the info that you gain and then puts them through a process and turns it into something you can make sense of. Alright, so now for our next little part, we're going to be getting into association areas, which I have two, and brain structures. Alright, so our first part of our association areas is the Broca's area, located in the left frontal lobe. It's responsible for speech production and language expression, helps you form and speak language and words clearly. Any damage to this area could just cause you to struggle to speak, like speak slowly or have your speech be broken up. Pretty important if you want to, talk. Alright, and then for our second part of our association areas, is the Wernicke's area. It's found in the left temporal lobe. It's involved in like understanding language, so stuff that is spoken or written, and that's about it. So it's really good how it pairs with the Broca's area. If the Wernicke's area is damaged, though, the person may be able to like speak fluently, but use like meaningless or jumbled words. Yeah, not good. Alright, so basically, first up of our brain structures is the thalamus. It's kinda like a train switchboard, like one you'd find in a train station, because it routes your sensory data to the correct destination, so then your brain can actually process it. Next up, the cerebellum. It's kind of like a gyroscope in a drone, as what it does is it maintains your balance, coordination, and it basically means you can actually do fine-tuned movements. So, quite important, like everything else in the brain. Alright, so the reticular formation, kind of like your alarm clock, as it regulates your sleep and wake cycles. So, when your alarm clock goes off in the morning, it's supposed to wake you up. Does not do that for me. Yeah. But yeah, basically, it does that and more, like filtering sensory information and coordinating basic uh, motor functions, along with your breathing, heart rate, and reflexes. But yeah, it's also the reason why you're, supposed to be waking up. Alright, next up to the thing that's like an automatic thermostat in your body, the medulla. What it does is it controls your involuntary processes, like a heart rate, breathing, blood pressure, to keep you alive. Kind of like how an automatic thermostat keeps your house from, well, either getting real hot or getting real cold. Alright, next is the corpus callosum. I think I'm saying that right. But, kind of like a bridge between your two hemispheres of your brain. Allows them to talk to each other, kind of like a village and a bridge between them. So, one village can say hi to the other village and bring gifts and stuff. You cut that off, they never communicate, and that's about it. And so then now that your brain has that, they can say hi to each other and work together. Pretty cool, and I think it's very important. Now that I think about it, I never went over the left or the right hemisphere either. So, the left hemisphere controls the right side of the body. It does language, speech, logical thinking, math, and reading and writing. So basically logic side, verbal side, that's what it's called a lot. Then the right hemisphere, it's controls the left side of the body. Yeah, they control the different sides. But the right side specializes in creativity, imagination. It's also the reason why you can recognize faces or patterns, spatial awareness, emotional expression, music, and art. It's often called the creative side too. And they have their strengths and weaknesses, and that's why the corpus callosum is so important. It allows them to communicate and work together on something. We call the right and the left side communicating contralateral organization. Basically, it's just the right side controlling the left side controlling the right. Um, Pretty cool, and that's why if you know anyone that's had a stroke on a certain side of their brain, you'll notice that the other side of the body is the one that's had the effects. So, kind of cool, not about the stroke thing, but yeah. Contralateral. Took me a while to pronounce that word, to be honest. Alright, so basically, hypothalamus. Um, Small region of the brain located near the base of the brain, above the pituitary gland. It's like a thermostat or a like control center. Uh, it does everything from hormone regulation, body temperature, hunger, thirst, sleep-wake cycles, emotions. Then it even gets into the nervous system. So it does a lot of regulation, kind of like how, thermostat tells you what's up, and then the command center, does something to fix that. Yeah, very important part. Alright, so glial cells, basically, they are the support staff of your brain. The support staff, they make sure stuff gets done correctly, right? So those supporting cells in your brain, they actually outnumber the amount of neurons and perform functions which are beyond simple structural support, like the blood-brain barrier. They're in that. Um, they do a lot. They're very important. And another cool thing is that when a neuron dies, they actually basically rip up that neuron and feed it to the others. Makes you feel good, by the way. Yeah, pretty cool. Support cells. Alright, so the hippocampus. Yeah, kind of like a librarian. Um, the hippocampus is basically the reason why you have memories and can learn. It's very crucial in the process. So, kind of like a librarian, how a librarian organizes and stores information like books for, future people. Well, kind of like how the hippocampus takes that information and stores it away for future use by only you. Because nobody else can really look at your brain like that. Alright, so now we're moving on to the neuron and its parts. Starting with the dendrites, it's like an antenna that receives signals from other neurons. So yeah, antenna receives signals from other places, and that's kind of how a dendrite works. Then the cell body, which is the soma, it's a control center, which it's the reason why the neuron lives. It's got all the stuff a cell has in it, and then it's like a control center because the control center has everything you need in it, and it also processes those incoming signals. And then we have the axon, which is like an electrical wire, which moves those signals away from the cell body. So yeah, like a wire moves those signals away from wherever it came from, and that's how that works. And then we got the myelin sheath, which is basically insulation on that wire, because when you put insulation on a wire, that wire is able to pit out more without, you know, having any issues. Basically, the myelin sheath speeds up that signal transmission. And yeah, those are the four main parts of a neuron. Pretty cool. You have a lot of them. A lot. Now we're going to quickly go on to neurogenesis, which, neurogenesis is the process of creating new neurons. It's like, it's pretty important, because you lose a neuron, you kind of want that back. It mainly happens when you're still growing up, but it does continue to happen when you're an adult, just a lot less. Mainly in like the hippocampus, which is memory, because you're able to form memories after like age 25. And neurogenesis plays a big role in your learning, memory, and recovery from brain injuries. Speaking of brain injury, we're going to talk about a concussion, which is your brain hitting the inside of your skull, the thing that's supposed to protect it. And brain injury or trauma, brain damage, it can result in some pretty bad things. You could forget how to do things like speak, because once that part of the brain is damaged, it doesn't just like grow back. So you could forget something. That's pretty bad. It doesn't mean that's like always gonna happen, but it's a possibility. Neuroplasticity is great because it's your brain's ability to change and adapt. And if you had a concussion and forgot something, you could just form a connection around that damage. It's a very good ability. You kind of lose this ability to use it very well after like age 25. But getting any brain damage is just not good no matter how old you are. It could leave you with lasting effects. And now let's go on to our body's messaging systems. So we have our nervous system, which you've probably heard before. Think of it as a Gmail, a really fast way to send messages, really fast way to send mail. That's kind of what the nervous system does. The nervous system is, well, your fast communication system. It sends signals from the brain down the spinal cord and the nerves. Basically, this message it sends are electrical signals from neurons, well, through neurons, to control quick and immediate responses. The nervous system handles senses, movement, reflexes, thoughts, and emotions. It's really quick. Just like Gmail. You send it, and it, well, is there. And now the endocrine system, and how it's like regular mail. So the endocrine system is, well, the body's hormonal system. It's made up of glands that release hormones into your bloodstream. And if you know how fast electricity is, really fast. Really fast. It's a lot faster than blood streams. But basically how it works is it sends chemical messengers, which are your hormones, to control long-lasting changes in the body. It regulates your growth, metabolism, reproduction, mood, and stress responses. The hormones that you send out, they travel through the bloodstream to reach certain organs. And so mail will be sent out and it'll take a little bit to reach there, and when it's there, they just have that mail. Alright, so let's compare them. Nervous system, very fast, milliseconds. Endocrine system, slower, just seconds, 2 hours, and possibly days, you know. The signals the nervous system use are electrical and chemical, while the endocrine systems are purely chemical, which are your hormones. The nervous system uses nerves to send out signals, and the endocrine uses bloodstream. Effect duration for the nervous system is short term, while the endocrine system is long lasting. The control you have on this for your nervous system, it's voluntary, like moving your hand, and involuntary. Your endocrine system is mostly involuntary. You don't usually control what goes on with that. Example is like moving your hand for, nervous system and reacting to like your environment. And then endocrines could be like growth, puberty, and stress hormones, all of that. They work together pretty well. They coordinate together to make sure your body is balanced. Here's an example. You get scared, what does your heart do? Races. That's your nervous system. And then your endocrine system, it releases adrenaline to keep you alert. Alright, and let's go over the signals that are actually sent out by your neurons. They're kind of called neurotransmitters. Basically, what happens is when a neuron does something, they tell it to another neuron. And the neurotransmitter that is sent out by the synapse. And what happens is that once the other neuron gets it, that neurotransmitter broken down or reabsorbed. And depending on the neurotransmitter, determine what the neurons actually do. So we have quite a few. I'm gonna go over two. Alright, so the two neurotransmitters we're going over is dopamine and serotonin. The main role of dopamine is reward, motivation, and movement. It acts in the brain for like pleasure and movement, and it's linked to pleasure, addiction, focus, and Parkinson's. Yeah, Parkinson's. Having too little does cause the Parkinson's and low motivation. Having too much can cause schizophrenia and impulsive behavior. It's an excitatory, mostly. Then we have serotonin. Its main role is for your mood, your sleep, appetite, and just overall well-being. The brain area is for regulation. That's where it is. It's linked to happiness, depression, anxiety, and digestion. Having too little can have you being depressed or mood disorders. Having too much is serotonin syndrome. It's kind of rare and it's caused by medication. It's inhibitory mostly. Alright, so now it's time to go back and I want to explain how the parts of the brain, just like everything works and fits together. And I hope it makes sense. Alright, so we're gonna first go back to our neuron. So I never did this yet, but I'm gonna piece together our neuron. So we're gonna start with our, antenna. Then we're gonna go to our control center. Then we're gonna put on our electrical wire, and then the insulation on that wire. But as you can see, if we signal through here, goes in here, pits it through here, comes out, and then gets sent off into another. Alright, I'm going to be quick with this one. So basically, your neuron releases a neurotransmitter, goes to the synapse, and then basically, it grabs onto that, to another neuron that's receiving this message, spits the message in, then it detaches, and basically, the sending neuron slurps it back up and recycles it. This is pretty good because you have like not an unlimited amount of neurotransmitters, but you make more. So basically, if you have too much, it'll just, instead of slurping back up, just kind of kick it off. But if it needs to build up its levels, it'll just slurp back up. That's how your body regulates its neurotransmitters. Alright, so let's bring it back out and let's talk about how the four lobes work together. And imagine you're looking at a painting, right? Your occipital lobe, which is your vision, sends visual details like color and shapes to the temporal lobe for recognition and to the parietal lobe for spatial understanding. The temporal lobe is your recognition and your language, which helps you recognize the painting as something famous, maybe. Understand what it shows. And you could find the right words that supports the frontal lobe. The parietal lobe, which is your spatial awareness, you understand the layout, how far objects are from each other, and make sense of what the occipital lobe sees. And your frontal lobe, which is your thinking and speech, organizes your thoughts, chooses the words to describe that painting, and controls your speech, and evaluates what emotions you are feeling looking at this painting. Your occipital lobe sees the world. Temporal makes sense out of it. Parietal figures out where things are, and frontal plans what to do or say. Each one sends information to each other. It helps the brain process complex experiences smoothly. We know that the four lobes communicate with each other, and so does everything else. There's neurons sending the electrical charge signals and neurotransmitters like dopamine or serotonin to regulate your mood and your motivation during your experiences. And reuptake's happening. All the lobes are involved. None of the parts work in isolation. Just the lobes are constantly sharing information, and the nervous system is sending them. The endocrine system is releasing hormones, and neuroplasticity, it allows your brain to learn. The brain is a dynamic system, and it has just so many parts that specialize in a few things, and they all work together. Seeing, thinking, feeling, moving, and adapting, all within milliseconds. It's crazy. Brain's kind of cool. And with that, I think my video is coming to a close. I hope that anyone watching enjoyed. I hope I get a 4 on this assessment. That's it for the brain, for my psych project. Goodbye.